Good afternoon, morning, and evening, everyone, and welcome to today's Titomic CSAT chat. Say that 5 times fast. Speed, sovereignty, and space, Titomic's global manufacturing mission. Around the world, governments and industry leaders are confronting the same challenge. How do we deliver mission-critical capability faster, at scale, and with resilient industrial capacity? The answer increasingly comes down to manufacturing speed, sustainment readiness, and sovereign industrial capability. At Titomic, we believe this moment represents a major shift in advanced manufacturing. We are not simply a technology company. We are a manufacturing and sustainment company delivering mission-critical products for defense, aerospace, maritime, energy, and industrial customers. Enabled by our patented Titomic Kinetic Fusion advanced cold spray additive manufacturing. Today, we're joined by Titomic's regional leadership from the United States and Australia to discuss how this shift is reshaping the global industrial landscape, from space systems and naval sustainment to defense readiness and production scalability. Will you please introduce yourself to the forum?
Sure, I'm Patty Dare. I'm the president of Titomic USA.
And I'm Aude Vigniel. I'm a Titomic president for the APAC region.
So we'll start with Patty. Patty, a couple questions for you.
Sure.
The US market is placing enormous emphasis on rebuilding industrial capacity and accelerating manufacturing readiness. Titomic USA has experienced major momentum recently, but what happened on the ground?
Well, there's a lot happening on the ground here. We've been here with our ribbon cutting June 2nd of last year. We haven't even hit our year mark. And in the facility that we're sitting in today, we have low, medium, and high pressure capability of cold spray. We also have become very vertically integrated because we didn't want to depend on others to slow down the process of our cold spray. So we've incorporated in a metallurgy lab, and we also incorporated into a machine shop so we could do things very fast for our customers. So we've got a lot of customer base here in the area and in the United States as well as globally, so you'll hear some of that. But we have major aerospace primes. And then the defense industry, we just had Honorable Undersecretary of War, Mike Duffy, in our facility today. So he was definitely talking to us about the speed and volume needed. And we think we have that capability here in Huntsville to provide that speed and volume across industries that Brian mentioned. Not only aerospace and defense, but oil and gas, the automotive industry, the food industry. So there are many different areas where we could really focus, but we've intentionally focused on aerospace, defense, and space in this area.
So Patty, I'm glad you touched on our visit today, because one of the major themes that we hear from the government and industry is that speed wins.
Yes.
How is Titomic positioned to deliver on that expectation?
So if you can think of the traditional castings and forgings, which take about 18 to 24 months that we're hearing from our primes just to get that piece in house, and then they have to machine 80% of it away. And then they have to do other post-processing after that fact. We can do from fine metal powders, cold spray them in a matter of hours from a simple computer program or CAD model and put it into our system without molds. So we can spray those parts pretty fast. And then with our post-machining that we have in-house and our post-processing we have in-house and our lab in-house, we can get products back to the customer within weeks or months versus 18 to 24 months just to get a casting or forging.
It's amazing. So I have a question for Aude. Aude, the global space sector is rapidly shifting from experimental programs to operational infrastructure. Governments now deeply care about sovereign manufacturing capability, rapid production, like we're saying, speed wins, and resilient supply chains. Where does Titomic fit into that future in your eyes?
I'm glad you bring that up because, as Patty said, we cover a lot of sectors. Space is one that is very close to my heart for a lot of reasons. First of all, maybe what I could say is at Titomic, we love solving problems. We are developing really cutting edge technology that's really interesting and passionating for me. I really love tech, but we are here to solve problems. We're developing applications to solve problems. And I think in space, there is a lot of problems to solve all the time. very drastic environment. It's vacuum, it's cold, it's hot. The weight is very important. Any weight that you add to launch is costing more money. There is radiation, so there is a lot of problem in space to solve. And also on the ground, let's not forget the ground segment. If you don't have a ground segment, you don't have any mission. And I'm talking about antenna, ground stations, and that are often submitted to corrosion and erosion, but a launch pad as well. We have a Starship launch in a couple of hours. I don't know if you've seen the state of the launch pad after a Starship launch, but it needs to be repaired, and we can help with that as well. So lots of problems to solve in space. So the cold spray technology is very applicable to that. The other thing I'd like to say is space is a critical infrastructure now. And before we were doing scientific mission, but now if you think of Earth observation, communication, position, navigation, and timing, we use this application every single day. So space is critical. So everything Patty said about scalability, about being resilient, about supply chain, about rapid iteration is now very, very applicable to space. And that was not the case before. I think in 20, 30 years ago, having a mission, space mission that would take 10 years from phase 0, so concept phase, to launching and operating, that was the norm. Today, you need to launch fast and you need to replenish your constellation. So our solution is very, very applicable for these problems.
That's amazing. Patty, I'll ask you a question. What misconceptions about cold spray technology do you most often encounter from potential customers?
So cold spray doesn't fix every problem, that's for sure, but rotational parts we can do fairly quickly. And when they come to the factory and take a tour, they're just amazed that you can go from these little fine powders into these giant parts. So they don't envision us being able to make huge parts up to 9-meter size parts. They can see you doing small little parts out of this powder. So I think a big misconception is, one, that we can't build the big parts. 2, that we can't do all the cutting edge things that we've been doing today. So we've done stuff that people have never done before. And 3, just what can they get in industry quickly? So they don't believe that you can really get these parts so fast because it's taken them so long to get traditional parts. So they don't believe that we can do it as quickly as we say. But just like Northrop Grumman, they came to us. Even before we had the factory up and running, they gave us a contract and said, can you produce this within like a 6-month time frame? We produced the pressure vessel that they hot fired within less than 4 months and delivered to them, and they were ready for their hot fire on time. So delivering parts on time, on schedule, and at a minimal cost, they just can't believe.
It's amazing. Ode, how is sustainability influencing customer interest in cold spray compared to the conventional manufacturing methods like forging and casting? That's that nature.
I'm glad you asked this because I think we need to brag a bit more about this because we spray just what we need. There is no waste. That's number one.
Near net shape.
Near net shape indeed. So that's one thing. The other thing is that because we spray fast and we manufacture fast, like Patty was saying, you don't need 18 months, 20 months to set up a casting or forging. We can do piece in a couple of hours or minutes, whatever the piece is. So we consume less energy as well. So the footprint that we're using in terms of carbon footprint is very reduced compared to traditional methods. Also, the application that we have on wind energy turbines, we are exploring all this, and there is also this sustainability market that we can address. So there is 3 aspects into how our cold spray technology is more sustainable than other technologies.
That is amazing. Patty, how critical are partnerships with governments, universities, and industry primes to expanding the market presence?
Definitely very critical. So the universities help us do qualification of materials. They can help us do research and development that we might not have time to do or the resources to do. The government definitely can help us qualify parts and have that ready to go. I know a lot of the primes want to qualify their own parts, and if you qualify for them, you can't share the data with other primes. So the government comes into play where they can help us qualify, and then we can share the data across the board. And that's one thing we're doing with NASA and the NASA Space Act that we have, that they're helping us do things such as that.
But if I can add,
Yes,
this-
absolutely.
this is not a small thing, this NASA space activity. With my background, and I know how hard it is to, so congratulations for Titomic to have made that happen. That's number one. And it's a testament to how cold spray technology has the potential it has for all these challenges that space has. And if I can go through some of the application, so I said, wait, so because we spray just what we need, people are very interested in seeing how we can build structure for satellites and space system because they're going to be lighter. When we talk about the stress that your structure are going through in space because of temperature and vacuum, we are inventing alloy every day. We're mixing powders, titanium with tantalum, with every day we are testing new powders. It's really, and for me, space is always pushing the tech to the boundary of what's possible, and cold sprays is pushing these boundaries even more. So the new property of the material that we are able to do with cold spray, because there is no heat either, are very interesting to explore. I'd like to talk about a TRL9 application that we have developed, because that's an Australian project. I'm very proud of it. We partnered with a company called Innovor in Australia. They are a spacecraft manufacturer. They were carrying Italian spectrometer, gamma ray and X-ray spectrometer delivered by the Italian Space Agency, so no small feats. And they looked at us and they asked us to look into the thermal management and the thermal radiator for this instrument. X-ray is very sensible to temperature variation, first of all, that introduce a noise, and you need to be very cold if you want to be able to observe space in X-ray. So the thermal radiator was really a critical, and you said mission critical element. So it was a very mission critical element. If you don't control the temperature, the mission is dead. And instead of building these pipes of copper that we usually do for thermal radiator, we spread an exact shape of all the modulation and simulation we did before to see how much heat this instrument will radiate, and what was the highest performance shape we could spray on that aluminum panel. And if you look at picture of this, it looks like an eagle with big...
It's online if you want. We'll send a link later.
Have a look, because it's a very interesting shape. And again, we spread only what we needed. So it's probably the lightest thermal radiator that has been sent to space. The spacecraft has been launched. It's been performing for 2 years. We've received fantastic picture of it. So this is an application of this TRL9 in space, and we're very proud about that and looking forward to do more on this. The other aspect I mentioned was radiation. Electronic is very sensitive in space for all the radiation bombardment you receive in space. And we are developed and tested on the ground some radiation shielding. So we are spraying different layers of different components, tantalum, titanium, aluminum, and we're trying to see what kind of wicks you need to spray. And we have tested that on the ground with a nuclear accelerator. So that's TRL45. We're looking forward to develop that more and to demonstrate that in space. When you think about all the data center in space that people are thinking of, and the lunar base station that we're thinking of, we need to protect the electronics of that. So I think there is a great application there. The other thing that we're developing is refractory metal for hypersonics, and that has an application in space for re-entry. When you look at the capsules that will come back and on Earth and enter the atmosphere, you can see that there is a lot of heat there. So looking into how we can do a shield for the heat is also something we're looking at. And then the ground station that I mentioned, so corrosion, we've certified this application with DNV. So new technology is always, the challenge is to certify that. It's new, so people are a bit like not wanting to take risk. We have certified this aluminum corrosion remediation. So ground station, when they are corroded because of salt spray or sea air, we can actually fix them. And I would really, really be excited to look into a launch pad of Starship and say, can we do a prevention coating of refractory metal to try to protect the launch base before launch? So these are all the applications we're looking at. And having NASA, Anna forgot to mention the rocket nozzle test that you mentioned with Northrop Grumman, which was really, I think they said it was a flawless testing, which is, again, not a small piece. You don't brag enough. And pressure vessels as well. So looking at all this application with NASA is really giving us so much credibility in what we are doing.
So it sounds to me like what you're saying is Titomic is out of this world.
And on Earth.
Patty, a question for you. What advancements in material capability are most important for the next generation of cold spray solutions, in your opinion? And I'll ask you the same question.
So we're working the next generation of cold spray solutions. As Ode said, we're doing refractory metals. These metals, a lot of them, the blends have never been done before. We're trying new and innovative things to test out to see how they're going to work, either arc just testing or testing them in other ways to see how they perform. So I think material characterization is going to be important for us going forward, but we're trying new innovative things every day, new materials. The customer will come to us, can you try this material? Well, of course we can try it. If it's metal, we can try it. We're even doing some ceramets today with their ceramics and metals mixed. So we're trying that as well. So if you have something that you need a solution for, like Ode said, we're your people to try those solutions to see if we can partner with you and make them work.
So Ode, how would you say the advancements, what advancements in this are most important for the next generation as we forge forth and build the future?
I have to concur with everything Patty said, and also trying to find the holy grail powder, because every metallic powder is different. Some are spheric, some are not spheric. Which one is the best for what? Because when you accelerate to Mach 9 air, sometimes the particles don't follow. So there is I used to say rocket science is there, but I think material science is up there. I'm learning every day. I love going to work and ask the material scientist, what are you working on today? And seeing what they're spraying on their microscope is almost art. It's fascinating. So understanding and defining the perfect powder for each type of application you need to do, and ensuring that, we secure that supply chain. It's our powder, it's our Titomic powder. We're blending with our own secret sauce. Being able to control end-to-end chain from the powder to the machining and the testing that Patty mentioned is very, very important. This vertical integration is going down to the powder and the metal where it comes from as well. And titanium is very important because we can't source titanium from countries we used to source it. Australia has a lot of titanium. Is it time to look into securing that supply chain? These are conversations I'm very looking forward to have back home.
So Ode brings up some really important points. Having strategic partners for powders in the United States is becoming critical for us. So the customers are demanding a lot of that. So we have partnerships that we have with multiple vendors right now, especially titanium is an important one for us. Another thing that's very important for us is to make sure that we have repeatability so we can scale and do production runs pretty quickly. So having the powders be consistent is very important. We're finding how important that is every day. So we have to make sure that we vet the vendors, know the powders. If we have our own powders, know how they're going to perform. So that's very critical too.
Ode, what are the key barriers, in your opinion, preventing a wider commercial adoption of cold spray technology?
I think I touched on that. That's a very, very good question. New technology, certification, validation, qualification. I think we're getting there. We have some announcement coming. We are working with key customers, but we can't announce them yet, which is frustrating because if we could, I think we would be able to accelerate. So for me, that's the biggest thing. The interesting thing is that sometimes when we have some machines in Ukraine, their qualification, certification lasted a couple of seconds. They had a hole in their radiator in their tank. They fixed it on the spot. They spread aluminum on the radiator. The radiator was fixed. They put water and everything was fine, and the tank could go back on the battlefront. Certification done in 2 seconds. in the project we are doing today, as Patty said, people come with the problems. Okay, what's the material we need to put to use for fixing that problem? And then testing it and elongation and all this kind of tests. It takes time. And then you need to have the recognized certification, the DNV, the Lloyd, and this takes time. And I'd like to have some challenges and some support from government to say, okay, if you can demonstrate you can do this, we're going to help you get the certification quicker. This for me is the biggest challenge to scale rapidly.
But O brings up a very good point. We have 9 units in the Ukraine today working on the front lines. And the reason that we have them there is the conditions that they're faced with today. So qualification, you're right, operates completely differently. They don't wait 3 years to go through a full qualification process. They need a capability today in the warfighter's hands, so they have it. So it operates a little bit differently depending on your environment. We're finding with the real world situations that our government here in the US is definitely interested in speed and volume quickly. So we have to replenish a lot of the inventory that we've depleted, and we have to move really quickly with various different processes. So that means taking a little bit more risk, being a little bit more innovative to get the job done. So that's where Titomic comes in yet again.
Patty, what applications are generating the most customer excitement right now? Was it repair, coatings, additive manufacturing, something else, or all equal?
So I wouldn't say all equal, but I would say the qualification does play into the production and getting things faster. So the additive manufacturing, I would say, is picking up more than it has been. I think getting the word out, I'll just tell you, a little over 2 years ago, I didn't know anything about cold spray. I didn't know it existed. I didn't know what it was. I mean, even one person when I was at a conference asked me, is it some kind of nasal spray? And I'm like, no, completely different than that. So getting the word out, making people understand and give them the education on what cold spray is, what it can do, how it can help them, definitely plays into what's more critical. So additive manufacturing, like I said, is really picking up when it comes to pressure vessels, thrusters, warheads, copper bands for ammunition, other ammunition or munition type applications. So it's becoming really important there. O mentioned earlier about oil and gas and the oil rigs. Because some of our systems are so portable, and we even have a backpack version now that we just demoed out in Hawaii that was loved by the Navy on the ship. So you can take these portable systems almost anywhere to do coatings and repairs that are needed where you wouldn't have to ship back a part necessarily. You could just go right on site and repair it. So that's really critical. And we're spending a ton of money every year on anti-corrosion or corrosion problems. So that's, again, where our systems could come into play, do quick coatings. We just got off the phone with a customer a few minutes ago saying, can you please come out here and try this and see if it's going to work? So we get that a lot too. So it just depends on the customer, their applications, and where they can see it working. And with all the tours we have coming in, it's like you can see the light bulbs going off in everybody's head. We can use it for that. Oh, we can use it for that. So there are a lot of different applications that are available.
If I can add to that, something that blew my mind is oil and gas. We have a machine on an oil rig since December. I can't mention who and why. But the key thing, which for me is a big, massive differentiator, is on an oil and gas rig, the classical way of fixing corrosion involved high temperature. With our system, no high temperature. So the oil rig can continue operate while you are fixing your corrosion.
Business as usual while we're repairing.
So you imagine, I don't know how many millions or whatever the numbers is of a day operation, but we are able to increase the uptime of assets. And that for me is super key. Reduce downtime, increase uptime. And that's applicable for oil and gas and energy, but also ships and boats. The first demonstration I did when I joined Titomic, we went to Garden Island in Sydney to do a demonstration, and there was a lot of valve and pumps. I thought valve and pumps was only a problem in space. It's a problem on boats and ships as well. There was a lot of valve and pumps on the table. Usually we take our prototype and you spray our prototype for a demo, but we say, okay, let's give it a try on the real stuff. And it worked very well. And we've been taken on the ship to visit where this equipment was coming from. As Patty said, we have a portable system. So you can even think, and we are getting this question, can I take this equipment on board? Of course you can. And we can even imagine these repairs being done while the ship is at sea. Imagine that, no dry dock anymore for a lot of repairs that can be indeed done while you're at sea, because there is million valves on the ship, and so that's that. And then when we think about AUKUS programs and a new submarine, I'll be really excited if someone would tell me this is the valve that is the first to be eroded. Well, give me the design, and I will, not the design, but how it looks like, and I will build it with the material of my choice, and give me the requirements and the spec, and I will prove you that the valve we're going to come up with is going to be better and perform longer. So we also want to be on this additive manufacturing for the new parts and the new project. And again, that's requires certification and proof and all that. But that's uptime for me was really like, wow, you can do so many things while operating. This is a big game changer.
So one of the things to add to what Oda's saying, we also have the long hoses for our medium and low pressure machines. And Chris, if he was here, he'd definitely bring it up. So Chris is our president in the Netherlands, and he couldn't be with us today. Unfortunately, he had to travel. But the long hose is about 20 meters right now. We're testing some longer hoses. So you don't have to have the equipment right next to where you have to spray or repair parts. So you can go into a submarine in certain areas where it's hard to get to in the hull of ships. So we were just out in Hawaii able to get to those really tight spaces so we could repair some things that normally you wouldn't be able to take a machine into and repair, but we were able to do that.
Patty, what would you say the biggest misconception about cold spray is that you run into?
Yeah, so we talked about some of the misconceptions from the customer. It can't do everything, as we talked about. So that's one of the things when people come in, can you do this? Oh, we will have it do this. And it's like, well, we can't quite do that. But there are a lot of things it can do. So misconceptions, like Ode said, she talked about the hot work permit not being required. So even though they see sparks coming when the gun is spraying onto a substrate, it doesn't mean that that's hot necessarily to a point where you would have to shut down operations. So it's a little bit different with the powder coming out and making that flash just because of the kinetic energy that's turning into the plastic deformation. So that's one of the misconceptions, that is super hot. We can't use it here, which really you can. And another misconception is that the powders, like I said, being able to take the fine powders and make it into giant parts. They just can't see that you're going to be able to get all that energy at Mach 5, 7, 8, whatever it is, hitting a substrate and be able to form a part like that and have the near net shape, have the properties that you get. So it's pretty amazing. You don't have all the voids like you could have in a forging or casting. So they just find it hard to believe that you can get that near perfect part so quickly.
And for me, that was, how does it bond? Really,
Yeah,
can it
yeah.
bond?
Yeah.
Especially with hard metal like
Right.
titanium, surely it cannot bond. Surely it's gonna fracture. Surely the ductability is not gonna be what we need. So we still have to demonstrate and convince, because it is just bonding with kinetic fusion. So
Right.
that is quite new.
And it's almost like seeing is believing.
Seeing is
Right.
believing, definitely. It was for me, for sure.
Yeah.
Same.
So, Ode, how are customers measuring ROI in this space and all the, whether it's additive manufacturing or coatings and repairs? Are they seeing the value
The value of
of cold spray, like when up from our additive manufacturing side to the time that they save? Elaborate.
exactly what Patty said.
Yeah.
Seeing is believing it. You're talking, you're explaining, you're showing video, and then they come to the facility and they see the samples that we have, and they see the sample being made, they see the machine working, and there is a big light bulb, and that's really 100% all the time.
And I think value too comes from the schedule, how quickly they can get the return part. They're saving so much time for labor that you would normally have, and the material casting, getting those is very costly, where powders are a lot cheaper. And then, like I said, with the powders, and Ode said it too, we have very little waste. So we're not throwing away the majority of that material. So there's cost savings there as well.
And the rapid iteration as well in the the example I was giving about the radiator for the satellite spirit, you try something, doesn't work, you can spray again and try again. So it's super fast. It's really fast to produce. It's very fast to iterate and test again. That fast and speed is really key.
And I would say return on investment too. We have a part sitting in our facility today from an oil and gas customer where they don't have a backup. So how do they repair this part? It's a small portion of that part that's damaged. They would normally just throw that part out and not using it. And that's hundreds of thousands of dollars out the door where we could, in a matter of hours, spray that part that was damaged and recover that part.
And sorry, the penny didn't drop when you asked me the question. Now, every time a customer comes with a problem to repair, we do exactly this. If you manufacture a new piece, it's going to cost you that. They give us the price. We need the cost, and we need to show them that if we fix it, this is what it's going to cost you. And we show they can
Show the balance.
compare if you produce 5,000, 10,000. So they see the value straight away. And sometimes we won't lie to them. It's going to cost you more than producing a new one, but that's maybe 10% of the case. So being very frank and honest and transparent about what Cold Spray can do for them, for their business. We're not a seller, we're a partner, and we work with people to solve the problems from beginning till the end.
Even like your trolley cars. Haven't you hit over 100 trolley cars that you've
I believe
repaired?
we have, yes. And the metro in Melbourne is exactly that as well. So
Right.
you can't produce these parts anymore. So
Right.
they come with something to fix, and we are their only solution. So
Right.
big return on investment there.
So this is a good question. How is Titomic, I'll ask Ode first, and we'll go to Patty. How is Titomic positioning itself against traditional thermal spray and additive manufacturing competitors?
So thermal spray easy because of the cost, first of all, and because of this hot process that they have that we don't. So that's pretty easy. And the work we're doing in oil and gas is, the word is spreading, and we're getting more and more people reaching out to us. In terms of other classical, I think the shape of the form and the size of pieces that we can manufacture, again, because we have the 6 degrees of freedom of robots that can turn everywhere and produce not any kind of shapes. There are some shapes that are not done for cold spray, but we can do large pieces, and I think we're the only one to be able to cold spray large pieces like that.
Yeah, I would definitely say the large pieces and the timing that we can do things and just how we can program pretty quickly to get those parts out, I think is a lot different.
And also differentiator is, I do believe we have the best material scientist team in cold spray in the world. I think in Melbourne, we were trying to see, we were reaching 250 years and adding the office in Europe and here of knowledge of material science, and you can't beat that. And passionate people will always go above and beyond to find the best alloy to solve your problem. And material science is, we are doing things that nobody has done before.
And I would say too, being able to spray disparate metals on top of each other, just one spray layer and then another one, as long as your coefficient of thermal expansion isn't that much different in between the layers, it just bonds directly with another metal.
And the other thing I'll add, not only we're chasing customers and application, but in Australia, we're doing a lot of R&D every day with university alone, and we try things. So we should try to develop that. We should try to do this. So we have lots of white papers that we're publishing regularly. Some we have to keep them close because the applications we want to keep that for ourselves. But we are doing a lot of R&D every single day. And I don't know a lot of companies who are giving such a big focus on R&D. Our CEO is a material scientist as well. So we're having good conversation, and we are supported in developing all these new applications. So that's delightful.
So we thank you for all the R&D you're doing because we leverage it every day. And I think the Netherlands too, and what they do, we try to leverage it globally so we can share ideas as much as possible.
Question, we're rolling into automation. So how important, Ode, is automation and robotics integration into the future of cold spray?
Very important. I think nobody can ignore that. Automation, AI, we are starting thinking about this. We're not there yet, but we are, especially in robotics. the conversation we have with people when they want to do corrosion or even with the handhelds, after a while, if you're spraying for 10 hours, your arm is starting to be, so we need to start automating these kind of things. Just now we're looking into what are the key applications, but automation is on the back of our heads and minds, and we are preparing the ground to take that leap when we can. AI, same things. We are collecting a lot of data in every spray we're doing, and we're starting running some AI programs to see what can we get out of that. So this is on the back of our heads, but it's maybe 5-10% of my activities just now.
I would say for low, medium pressure machines, we can hand spray, but we can also put them in a robot so they can spray as well. So I think we've looked at automation there. We were on a call with a customer today going over, what kind of robots can they use to spray all these activities for their application specifically. So I think we're going to get more into that for each of the customers because they have so many things to repair and coat that they're not going to be able to hand spray everything or even use like a gantry to do that. They're going to have these actual robots. I know I was just down at Louisiana State University. They're doing a lot of the robotic activities too for welding today. So we're looking into that and see how we could potentially partner with them and get some more automation. And there are other universities that are doing that as well. So we're looking for that capability.
And maybe, so that's a repeatability that we're
Yes.
looking at doing as well.
Mhm.
Now, because we are 3 sites in 3 different locations, often when we can in Melbourne, we're developing a prototype. And then when we find the secret sauce and the configuration that is good, we send the configuration parameters to Europe or to the US, and it's press the button and it's there. So this preparation path for automation is there as well. How can we prove? And we have proven it, and we were very proud of being able to prove that because it's not as simple as it sounds. Being able to develop something in a location and repeat it in another place means that we can share a lot of development we're doing, but we can also, when in Europe they have so many things to produce, they need overflow, we're here to help. And that's super important. This having a company that has a global footprint in Europe, in the US, and in APAC is very unique.
I would say too, we're using augmented reality now, and we're trying to find ways to improve on that. So we have the gun set up today so we can click different powders and show operators how to spray and what the distance needs to be when they're hand spraying. We'll do that too with the automation and have that programmed into the machines. But we're also doing a digital twin, so we can go in and do a digital twin of an environment and capture that. So if a repair is done or needs to be done, you could go point out, I need this area repaired, this area repaired. So when the technician goes back in, they know exactly what areas they need to spray. And then it will capture that data to show what we have repaired for their future reference as well.
And that reminds me something that I should have answered earlier when you said challenges, training.
Yes.
We have welders. We are the cold sprayers. And this AI tool, a virtual reality tool, which I tried a couple of times, is a very good tool to train more and more people. And that's something we need to think of, partnering with a university or a school or a TAFE or whatever it is to be able to have people who are, I am cold spray certified. This is a new job that we are developing as well. And we need to develop that workforce, and we need to think of doing it now. So that's another challenge that we need to overcome, but we're working on it. Sorry, there was a question you were asking?
No, that's actually perfect because we're rolling into this. Patty, how are workforce development and operator training evolving as this technology matures?
Yeah, so as I said, universities are important for that role as well. We are looking to partner with a local university here that does welding in a technical school. So we can incorporate that in as a module to potentially their welding curriculum they already have and have a separate certification for cold spray. So we're looking at that for workforce development for sure.
You see, that proves that we didn't prepare.
No, this is happening. This is happening. So what lessons, Patty, have you learned here in the US market that may help accelerate APAC and APAC likewise? What are the lessons that we're learning in each respective region that can help each other?
So we are learning a lot of lessons here of how to set up parameters, what material characterization needs to be done, how we interact with customers in general. The products that we do here, we need to be able to share as much as possible with Ode and her team and Chris and his team, so we don't duplicate efforts. We found out that some of the applications that we were doing here and things that we were trying to be innovative about, they already did. So sharing the information is critical. Like the long hose, we were off trying to do long hose studies here. And then we got on the phone with the Netherlands and they say, oh, we've already done that. We'll ship that to you. It's like, so lessons learned like that happen all the time. Or Ode's already done research on a specific material and we were starting to do research. It's like, oh no, we can help you with that. We'll send that over tomorrow. So things like that are definitely.
So
things
we're
that we can do.
fixing that, but for me, the big force we have is there are a lot of customers who have a global footprint as well. All the primes exist in or have an activities in the US, in Europe, and in Australia. We are the only one to be able to offer them a service everywhere. We can't share everything. There are some secret things that are happening in the US, secret thing in Europe, secret thing in Australia. And under AUKUS, we can share much more. Again, I think we are the only companies who have the AUKUS footprint like that and being able to support both Pillar 1 and Pillar 2. That's a great force and a great differentiator. So we are not only sharing the knowledge and the lesson learned, what we're developing, but also we are sharing our approach to common customers. And often we had some calls with companies where it's so great to have you because the information flows better because we are in the same situation, and that's very unique as well.
We have set up a global SharePoint so we can start populating because we're on very different time zones. So we found out there are very few times that we can all get together at a decent hour for us all. So we have set up that global SharePoint so we can start communicating better, sharing data better. So a lot of lessons learned with that as well. So it's been a little rocky at first, but we're getting there.
But we also learned who is a morning person and who is a late night
Exactly.
person.
So Chris Myers, president of EMA, couldn't be here, but I had a couple
Yes.
questions for him, so I'm hoping maybe both of you
Okay,
can answer.
sure.
So we've all seen how modern conflicts have exposed supply chain vulnerabilities and the importance of operational repair capability. What lessons have we taken from the Ukraine situation out there?
So we can't know a lot about what they're repairing in Ukraine on the front lines, but we have learned that they've used our competitor powders in their machines and it works fine. So we've learned that. We have learned that they like our machines, so they've requested additional ones. So that's a very good sign. I think that's all I can share on that.
Yeah, and how easy they are to operate as well.
Yeah.
I think they really like that. And for me, what I noticed as well, to be able to have this capability now, it's like you don't have to set up an office. It's very portable. Even the high pressure machine, we can sell a cell where everything is integrated. So it's very portable. If anyone asks us, can you build this capability here because I need it, even if it's a high pressure machine, I think today we're able to deliver them within 6-9 months. So we can help people building their sovereign capability. We train them on how to operate the machine, and then we help them developing the application because they can't develop that themselves yet. But yeah, being able to help people develop their industrial capability, sovereign industrial capability, is a big tick as well.
I'll just say too, we took one of the ruggedized machines like we have in the Ukraine to the event in Hawaii for PBDE, and they were very impressed of the portability of it, the ruggedization of it. So they were more interested in that version of the machine and the backpack versus what we thought they would be more interested in. So getting that feedback from the customers is definitely important. We are still trying to get more feedback from the Ukraine. But in the meantime, just getting all this equipment in the hands of the government, the warfighter, the universities, so they can tell us feedback where we can incorporate it into our systems, I think is very helpful.
And we're building a roadmap with all this feedback we get from customers and integrating that into the next version of the machine we're building. Some will be probably customized for some typical customers like aerospace and oil and gas. They have different requirements, but yeah, we're having a very structured roadmap to make the product better and better.
Still want you both to keep your Chris hat on. Do you believe cold spray enabled sustainment becomes the standard capability within naval and defense infrastructure? I know naval is very near and dear to Chris.
Does it become the sustainable?
Standard?
Yeah, it's
The
The
standard?
Yeah.
Yes.
I think for corrosion, definitely it's a capability that they have to have and they're going to continue to need, not just naval, but oil and gas and other industries as well. So Chris will definitely say, yes, it is definitely needed
But-
and going to be the standard.
It's not the only one. Last time I went to Perth in Western Australia, there was a US submarine, a UK submarine, an Australian submarine. So really AUKUS galore there. When they saw our capability, you know, I think I can vision a hub to sustain all these AUKUS ships and boats there, and everybody was on board. And some are more advanced, some countries are more advanced in the adoption of it. But I think we have a key opportunity there to do, especially in Western Australia. So I definitely believe that it's going to become the norm and standard, and I can see it becoming that way.
And just to bring up the UK, so we do have a UK subsidiary now. We are partnered with TWI, the Welding Institute there. We have equipment at their facility, so we have that capability in the United Kingdom as well.
Shout out to the United Kingdom.
That's right.
For both of you, we'll start with Ode. Looking ahead, where do you believe cold spray technology will have the greatest disruptive impact?
I'm maybe biased because radiation shielding for me is a big one, not only for space application, but on the ground as well, for nuclear submarine, for nuclear plant, for any standard reason. Semiconductor is also somewhere where I want to play more and more because we haven't looked at that, and I can see that I have an intuition and there is a lot to be done there.
Patty, what do you think?
I would say the most disruptive would be to the casting and forging industry, because we could replace a lot of castings and forgings that take a lot of time today. I would say specific part-wise, definitely propulsion, the solid rocket motor propellant vessels, the warheads, the thrust chambers, everything that is like the circular pattern that we can do rather quickly with metals, I think can be very disruptive.
Yeah. And the corrosion thing, I know at home are a few things that I like to fix with corrosion, and I'm dreaming of having one of our systems that you could buy in a retailer. Like, I don't know what is the equivalent of your Bunnings here, but the hardware shop, can I buy one and just fix all my...
Like a TKF 001.
Exactly right.
So we're getting ready to wrap it up here. Ode, if you could give one message to customers and to industry partners about the future of cold spray and Titomic kinetic fusion trademark, what would it be?
Come and talk to us. Whatever problem you have, whatever it is, come and talk to us and give us a chance to prove you that we can solve your problem. This is really my big ask. I want to solve more and more things. I want to have more and more challenge in front of me because we have the team and the technology to do it.
How about you, Patty?
I would say we're not just tied to cold spray, so we can partner with other people too. In case cold spray doesn't answer the whole problem, we can partner with others that might have another solution that we could work together to give the customer the very best possible. But I'm definitely with Ode, seeing is believing. Come see us. We'll tour you around and open your eyes to the opportunities and possibilities that Titomic can bring to you and to your business.
So with that, we will close. Oh, we have three questions.
Questions.
Let me get the questions here. We have three questions from the audience. Ode, how do you see titanium cold spray evolving over the next 3 to 5 years? Titanium.
So titanium has a lot of properties, refractory, and there is a lot of application there. Again, because Australia has the biggest resource of titanium, I would really like to see how we can secure the holy grail titanium powder produced in Australia and secure that supply chain. That's, for me, a bit of a passion I'd like to explore.
Patty, what do you think?
I think titanium used to be a lot more expensive, especially getting in a casting or forging, where people weren't necessarily relying on titanium to do their parts that they can now because the powder application and doing it so quickly.
Okay, I have a question for you, Patty.
Okay.
Where is cold spray and cold spray additive manufacturing at with regard to qualification? MQ, OQ, IQ, PQ.
Oof. That's a question for you.
I'm gonna get, you're going too, Lord. Don't worry.
You can go first if you want.
Let's see. Well, what do you think?
I think I'm not familiar with this term.
Yes.
Maybe that's just me,
Yes.
but I think I did mention the qualification was a challenge, but we are finding not only getting the qualification, but getting the right qualification,
Yes.
because maybe all these are standards that I should be across. I'm learning every day, and I have no shame in saying that. We have DNV today. For maritime, do we go to Lloyd? Every customer has a different request. So there is a lot of program in Australia as well to get qualification to be on this program. So this is my challenge today. What is the right qualification for cold spray today, depending on the application? It's not an easy answer.
Yeah, and I would say it depends on the application. Like Ode says, some things were TRL 9 with her Hermes satellite, and some things were TRL 2. So we've got that wide variety depending on the application, the material, what they want to use it for, where we are on the qualification process. Like she said, we're DMV certified. We're going through the NASA certification with the Space Act agreement. We're going through, we're ISO certified here, AS 9100. Even cybersecurity certification is a requirement for a lot. So we're CMMC level 2. So it just depends on the customer, the application, what they're going to use it for, and where we are in the process just depends on that.
Okay. I'll throw this in the middle, and whoever wants to grab it can grab it. Can your spray chamber be upgraded to a sealed system for the usage of helium at a site with a helium recycling system?
Yes. So the systems that we have in the back today, some of the high pressure systems can use either nitrogen or helium. And yes, it can be used with those gases, and it is a sealed environment that it operates in. And you can do mixtures of nitrogen and
There's all
helium.
the safety that goes around it, yes.
Yeah.
All right. Well, I would say this, for all the questions that we have out there, because we don't have access to them, please shoot us a line and we will get all of those questions answered. And with that, today's discussion reinforces a major reality shaping the global shaping the global industrial landscape. Manufacturing capability itself has become strategic. Governments and industry are prioritizing speed, scalability, sustainment, and industrial resilience at levels that we haven't seen in decades. Titomic is uniquely positioned for this moment, not simply because of advanced technology, but because of our because of our ability to deliver mission-critical manufacturing and sustainment capability at speed and at scale. I want to thank Dr. Patty Dare and Ode for sharing your insights today.
Pleasure.
And thank everyone for joining us. So we're excited to see what comes next for Titomic and for the future of industrial manufacturing, additive manufacturing, coatings and repairs, and all things cold spray.
And come and visit all of our locations.
We
Indeed.
have 4 to choose from.
We got 4 to choose from.